geocentrism, one of my favorite topics, because, as you know, Galileo fought with the Catholic Church over this matter, and the church condemned Galileo's views and said the earth is standing still in space, not moving. And they based it on scripture, they based it on the fathers of the church, they based it on scientific logic. And me being a Catholic, I took a special interest in that because for the last, 500 years or so, the church has been, I don't know, pounded, made a fool of, made fun of, because they told Galileo he was wrong. And everybody today thinks that, the earth goes around the sun goes around the galaxy, blah, blah, blah. And the church has had to suffer for that. So I made it my mission in life to show that the church was right and Galileo was wrong. And so the church does not deserve all the criticism that she has received and is given to us by God as a sure guide into things that look just like this, especially spiritual things. So once the credibility of the church is restored, I feel that I've done my job. And that's why I do this. So.
All right, Robert, I appreciate that introduction. I understand that you've written a lot on this, you've debated this, and you've also put out a documentary on the topic. So it is a privilege to have you here specifically engaging this topic. So for anybody who wants to see more from Dr. Robert Sungenis here, please do check the description box. I've got my chat mod in our live chat tonight, posting the links, the relevant links to our guests. Okay, Grayson from Base Theory, good to have you back as well. A little bit about yourself and how have you been?
Hey there, I've been well. You guys know me. You probably don't love me, but I'm here on the channel a lot with a lot of debates. This will be my first debate on the topic of geocentrism, so I'm pretty excited for that. I've watched Robert's documentary, The Principle. I've read some of his works. I'm pretty familiar with some of what he's going to say tonight. So I'm, feel reasonably assured that he's going to try to dress it up with a lot of scientific jargon. But at the end of the day, he's going to be making some very, very silly arguments. So get excited for that. That's all I'll say for the intro. Let's have some fun.
Okay, I can tell this is going to be a debate to remember, and I think it's going to live up to the hype. So I appreciate the energy, gentlemen. I appreciate the introductions. And so, yes, I'll say we have hosted on Standing for Truth. We do this full time. We've hosted about 325 debates on all sorts of topics: creation, evolution, nature of God, soteriology, you name it. But this is our first debate on geocentrism. And so that's why I am pumped to have Robert and also Grayson here to engage this topic. So for the audience sake, let's go over the format. So we're going to have 15-minute opening arguments. Robert's taking the affirmative, Grayson the negative tonight. Then we're just going to jump right into a free-flowing discussion. And so we're going to be comprehensive. We're also going to keep it as equally timed as possible, focusing on one topic at a time, as we like to do in these debates. Then we're going to get you guys in the audience involved. And so I know you've probably got questions you're dying to ask. So please tag me with your questions, either at Standing for Truth or at Donnie. Let me know who the question is for. If it's for Robert, let me know. If it's for Grayson, let me know. We'll have some fun for about 25 minutes worth of audience questions. And with that, we're going to get right into it. So Dr. Robert Sungenis, whenever you're ready, the floor is yours, and you've got about 15 minutes.
Okay, thank you. Well, let me see what silly arguments I can muster here. I like to start with Isaac Newton because he basically was the first one to put equations into the heliocentric theory. And that's important because you need to know where the forces are coming from when you say, the earth is going around the sun or the sun is going around the earth, as opposed to Copernicus, Galileo, Tycho Brahe, Kepler, and the Greeks that came before that, and Ptolemy. they all produced what we call geocentric model or geometric models, wherein you try to show how, if you believe the Earth was going around the sun, you showed that and all the planets and everything. If you believe that the Earth was fixed, then you showed geometrically how the sun would go around and carry the planets. And there were many different models that one could choose from. Okay. So, but all that, as I said, is geometry. And then when you come to Newton, you get an equation, probably the most famous equation we've ever had, and that's F equals ma. Force equals mass times acceleration. And in that equation, you have the mass, and let's say it's the mass of the Earth. That mass of the Earth has to accelerate, and that's where the A comes in. So m times A equals mass times acceleration. That's the force that the Earth is going to need to go around the sun and not get caught into the sun or not go out into outer space. There has to be a certain acceleration and a certain mass of the Earth that fits into that formula, and it has to be exact. Otherwise, the Earth is going to be sucked into the sun or the Earth is going to go out into outer space, one or the other. Okay. So that's what Newton gave us. And he said that this proves that the Earth goes around the sun because this mathematical equation can be proven in other. You can use F equals ma when you drop a ball from a tower and watch it fall. You can put F equals ma on that and figure out what the force is. Okay. Or if you put a rocket into space, you can figure out what F equals ma is. So that equation, as he said, is universal. Okay. So he was pretty persuasive with that argument that I have proven that the Earth goes around the sun. And not too many people on the geocentric side could debate him on that issue because they were all dealing with geometry. He was dealing with force laws, something very new in science at that time. So 200 years went by until someone actually challenged Newton on his heliocentric theory. Oh, and one more thing that Newton said was that because the sun is bigger than the Earth, much bigger than the Earth, that means with that mass, it's going to have a lot of gravity because in Newton's equations, mass, the more mass you have, the more gravity you have. So if the sun is much bigger than the Earth, of course, it's going to have more gravity. So the sun is going to pull the Earth into the sun. The Earth is not going to pull the sun into the Earth. Okay. And we would agree with that. Okay. As a matter of fact, we agree with Newton's equation, F equals ma, and some of his other equations. They all make sense. Okay. So then why do we believe in geocentrism? How can we do that? If Newton's theory seems so airtight, then how do we get to the place that I'm at? Well, 200 years after Newton, someone challenged him, and his name was Ernst Mach. And we know the name Mach when we talk about jets going at supersonic speed, Mach 1, Mach 2, Mach 3. He's the guy that showed us that. He also showed us a lot of other things. And one was that Newton made an assumption in his heliocentric system that he should not have done, or at least he should have kept open to the idea that there could have been another system wherein his equations would still work, but they would not come out with the same result. That is the Earth going around the sun. And the thing that Ernst Mach told Newton was, look, Newton, now, of course, he's 200 years ahead of him, okay? He's not talking to him. I'm just, making up a little drama here. He said, Newton, look, you can't assume that the only two objects in the system are the sun and the Earth, okay? Can't do that because there's a whole universe out there. And you see them, the stars, every night. As a matter of fact, we know that there's probably to 20 sextillion stars out there. Okay. If you add them all up, that's a lot of stars. Okay. And that's a lot of gravity, as a matter of fact. So you have another gravitational force that you have to deal with besides the sun. You just can't eliminate all those stars out there and then confine your system to the sun and the earth. And that's basically what Newton had done, because he believed space was absolute. He believed time was absolute. And so if that's the case, if space is absolute, that means it can't move. And it really is inert. It has no effect on our solar system. And that's the way he thought of the universe, as an inert, non-rotating, non-moving entity that really had no effect on our little system here. And look, we would all agree, if you're going to limit the system to the sun and the earth, then Newton's correct. And I wouldn't be here tonight. Okay. But that's not the case. We have a whole universe out there, and that affects things. Even at the end of his day, Newton admitted this. He admitted that, look, if there are other forces outside the solar system, then it's possible that the Earth could be in the center of the universe and the sun would be going around it. Newton himself said that. That was on the last page of his Principia Mathematica that they just found a few years ago, as a matter of fact. Okay, and I'm privy to that, and I know the guy who found it. At any rate, so things changed. And then when Einstein got into the picture, he developed his relativity theories from Ernst Mach. Okay. And in Einstein's general relativity, which came in 1915, he admitted that, okay, the nature of relativity is such that you can have the Earth in the center and fixed and have the universe going around it every day. Or you can have the universe not moving, and you can have the Earth rotating inside of it, and it would look like the universe was going around. Okay. Either one of those two are possible in Einstein's general relativity. Okay. So once we know that, then it becomes a game of, okay, well, which one's correct? Is it the Earth fixed and the universe going around, or is it the Earth spinning on its axis and the universe is standing still? Which one is it? Well, unfortunately, general relativity can't tell us, okay, because all it deals with is relative things. It could be this way or it could be that way. All right. So what do? Well, there were experiments that were done in the 1800s, especially. How much more time do I have, Donnie?
Good question. Let me check your timer real quick, Robert. You just hit the 8-minute and 50-second mark, so you got about 7 minutes.
Okay, good. We're doing good on time. Okay, so in the 1800s, some experiments were done. And I'm going to just go to a couple of them because they're more important. And one of them was by this guy named George Bedell Airy, A-I-R-Y. He was a astronomer from England, very famous astronomer. And he did an experiment, and he put 2 telescopes on the surface of the Earth pointing to one star. One of the telescopes had water in it, and the other had air. And the reason he did this was he was going to prove whether the Earth was moving or not. And the way he figured it would work out is the starlight would come from the star, of course, and it would go into each of the telescopes. If the Earth was either revolving around the sun, but especially rotating on an axis, then what would happen is the light coming into the telescopes would be at an angle. And because the light beam had to go through the water in the water telescope, it would slow the light beam down, and the light beam would eventually hit the wall of the telescope before it hit the eyepiece of the telescope. because it wasn't coming in straight, and then it was bent again by the water because the light beam was going slower than it would be in air. And so he did this experiment, and what did he find? Well, he found that the light beam did not hit the wall of the water telescope, and of course did not hit the wall of the air telescope. It went straight to the eyepiece of the telescope. Okay. So what does that mean? Well, the experiment was called Airy's failure because he failed to show that the Earth was moving. Because everybody knew that if the Earth was moving, then that light beam should be coming in at an angle from the star, but it wasn't. So that meant the Earth was fixed. It wasn't moving. And the star was so far away that any movement of the star up there wasn't going to make the light beam come in at an angle. Okay, so they already knew that as well. It was just the Earth that was the fulcrum here. Is it moving or not? So, okay, that was in 1871. All right. And so everybody's scratching their head. How are we going to answer this Airy experiment? And nobody could. Nobody. And even to this day, nobody can answer the Airy experiment. Why that light beam did not come in at an angle. So, they said, all right, let's do some more experiments. So Albert Michelson, he made a very fancy invention called the interferometer. And this measured the speed of light down like to degrees that we really didn't need, actually. It was such a great invention that he could measure one light beam against another and show you which one's going faster. That's how delicate this machine was. And it did it by measuring light waves. So he did an experiment in 1881. He did it first, and that was a little shaky because there was a lot of vibration. So they put it in a mercury bath in 1887, and everything, the vibrations were taken care of. So they knew they had a very accurate machine. And so they measured, they assumed that the Earth was moving 30 kilometers per second around the sun, and they shot a light beam in that direction on the surface of the Earth. And they figured that because the Earth was going through space, which everybody knew had to be filled with something, and that at that time they called it ether, that it was going to impede the speed of the light. Okay. And then they shot another light beam straight up, north and south, that wasn't obviously going against the movement of the Earth, as the control light. And then they let the light beams meet back together, and to see if the light beam that they just charged with the rotation or the revolution of the Earth around the sun was going to be impeded or not. Okay. And it wasn't. The light beam went the same speed east and west as it did north and south. Okay. And again, everybody's scratching their head. What's going on here? Because look, the Earth is moving pretty fast around the sun. At least we believe that. And so this light beam that we're shooting into space should be impeded in some way. And we know exactly how much it should be impeded. They could figure it all out. Okay. And it wasn't. So what are we going to do? Look, we've been taught since the time of Copernicus that the Earth is moving, and these experiments are telling us that it's not moving. So what do? Well, they were scratching their heads for 25 years, basically, on this issue until Albert Einstein came along, and he said, all right, here's what we do. We get rid of this idea of ether in space. That way the light won't be impeding against anything. Okay, there's nothing there to resist it. So we get rid of the ether. That's one thing we can do. And the second thing we do is we say, instead of making the Earth constant, that is not moving, we make the speed of light constant. You see, he basically had two choices. Which one are we going to choose?
1 minute.
I got 1 minute left.
Yes.
All right. So he did that experiment. He made up his thing. That's called special relativity. Okay, that's where special relativity was born, right there, to keep the Earth moving when all the experiments showed that it wasn't moving. Okay, and then Michelson did another experiment in 1925, and same kind of interferometer experiment. And he was going to measure the rotation of the Earth, supposed rotation of the Earth. Okay. And he did his experiment and he found 98% of a sidereal rotation. Okay. That's almost 24 hours. Now that's interesting because whereas he found a rotation, he did not find a revolution of the Earth around the sun. So the experiments were based on the same principle of light wave interference. Okay, so why am I getting a full rotation but no revolution? Because if you're a heliocentrist, this is going to bother you. Because if you're a heliocentrist, you need both a revolution around the sun, okay, and you need a daily rotation. And without those two, your theory is falsified. You have to have both of them, revolution and a rotation. Okay. But here's where the geocentrist comes in and says, I got the solution for you. The solution is there is no revolution of the Earth around the sun. That's why you're not measuring any. Okay. And you do measure rotation. Why? Well, because the universe is daily rotating around a fixed Earth. That's why. And that's why you got 98% of it in your experiment. Okay. So we have two experiments done here that show, at least prima facie, that geocentrism is not only viable, it's true because the experiments don't lie. People lie, but the experiments don't lie. Okay. So that's how I would open this whole discussion.
Okay, Robert Sungenis, thank you very much for the opening statement. I know these opening statements fly by, and so I appreciate it being comprehensive. Lots of great points to discuss. So we're going to hand it over to Grayson now. Before I do, Grayson, I will let the audience know we've got a lot of engagement in the chat with a lot of different views and opinions, and lots of great questions coming in. So I'll let the audience know that I am all caught up on questions. And so, Grayson, whenever you're ready, your opening arguments, and the floor is yours.
All right. So, yeah, my prediction was confirmed. There was a lot of scientific jargon dressing up some very, very silly ideas. So let's start this list of silly ideas with Mach's principle. That was one of the first things that Robert brought up by Ernst Mach. So just to give you an illustrated, to give you an illustration of what Mach's principle states, right? If you're standing in a field at night, looking up at the stars, right? You don't see that much movement in the stars, and your hands are down by your waist. If you start spinning in a circle, all of a sudden you look up and it looks like all of the stars are rotating. And then all of a sudden you feel this centrifugal force that's pulling your hands up to your side like this. Now, what Mach's principle states is that the force that you're feeling that's pulling your arms out to the side is caused by the perceived rotation of the stars. Does this sound silly to anyone? It should sound extremely silly, and that's because it is. And that's all that Robert's argument was saying that, oh, well, the forces that we experience must be coming from the distant rotation of these stars. It's the exact same logic. It's silly in both instances. He then made a bunch of incorrect claims about general relativity. I've heard his debate stuff before. He doesn't really understand either theory of relativity. But then he went on to talk about the experiment done by Airy. And what Airy's experiment showed is that there's no ether. Okay, like he left this out in most of his explanations for the Michelson-Morley, for Airy, for all of the experiments that he brought up. The results of those experiments show that there's no ether. That's it. It explains the results of all those experiments. So, for example, in Airy's experiment, if there is no ether and light moves at a constant speed in a vacuum, c, then the results of Airy's experiments are exactly in line with what we would predict. They're not in contrast at all. Again, if there's no ether and c is a constant speed. So he thinks he's pointing out a contradiction, and he left out all that stuff about the ether and the constant speed. He just says, oh, nobody could explain it. Yeah, well, Einstein did explain it when he put out the special theory of relativity and showed that c is a constant. And yeah, there you go. There's no ether. The Michelson-Morley experiment that he brought up also shows that there's no ether. He thinks that this shows that the Earth does not move, but what it shows is that the Earth does not move through the ether, and he is leaving that out. So I agree with Robert that the experiments don't lie, that people lie. And he is lying by omission by leaving out these crucial details and context. The Michelson-Morley experiment proved ether doesn't exist. We're not moving through the ether. It didn't show that the Earth is not moving. That is kind of silly. He also talks about Michelson's experiment from 1925, which showed that the Earth was rotating. So it demonstrated the Sagnac effect, which only happens in a rotating frame of reference. So there you go. It literally hit the experiment that he brought up shows that the Earth is rotating. We can look at lots of other stuff like Foucault's pendulum, laser gyroscopes. All these things show that the Earth is rotating. It's empirical validation of the Earth's rotation. Now, Robert will reject all of this. And he'll say that, well, if the rest of the universe is rotating around a fixed Earth, then we would expect to see the same thing. And what he's doing when he does this, and, I could get into all of the details. I could explain to you stellar parallax, how we know that geocentrism is wrong. But Robert's response to all this is just saying, well, if the whole universe revolves around the Earth once every 24 hours, then it would impart all of these forces like the Coriolis onto the Earth due to some Mach's principle, which, by the way, Mach's principle is not consensus science, never been proven. Nobody takes it seriously except for geocentrists and flat earthers, which they use a lot of the same arguments. You'll notice in any flat earth debate, they all bring up Michelson-Morley. They all use it the same way that Dr. Sungenis does. So there's a lot of overlap there, even though I know that Robert is not a flat earther. So whatever, kudos to him on that, I guess. So yeah, just to illustrate what all this comes down to, because like I said, we could go through the specifics of the science, but no matter what I say, it all is going to come down to Robert's central argument that he is making. This is the complete key to his entire argument, okay? And he'll say that our observations would be exactly the same if the Earth was fixed and the universe is rotating around it. And all he's doing there is talking about inertial frames of reference. This is true. The statement that mathematically, physically, nothing changes depending on your inertial frame of reference, sure, that's factual. You can pick any arbitrary inertial frame of reference. Robert picks the Earth, but you could also pick Mars or Pluto or anything that you wanted that's an inertial frame of reference. That is something that is not accelerating. So for instance, if I were to fall off of a skyscraper, right? I'm moving, my acceleration is not changing or whatever. I become an inertial frame of reference. So it is accurate to say that there are two ways of viewing that. Just like he was saying that you can view either the universe as some sort of fixed inertial frame of reference, which, by the way, there is no fixed inertial frame of reference. That's the whole point of relativity. But he's saying that there are these two ways to view things. Well, yes, that's true. There are these two ways to view things. For instance, if I'm falling off a skyscraper, it is completely consistent mathematically to say that I am not moving at all. I'm not falling. The rest of the universe is moving around me, and the ground is moving to come up to meet me. Now, if you told anybody this, you'd probably be laughed at, and they would consider you silly and ridiculous. But this is the exact same logic that Robert is using to make his point about the Earth being the center of the universe. It's the same logic. It's equally silly and ridiculous. If you think that when somebody steps off a skyscraper, they're not actually falling, but the rest of the universe is moving up to meet them, that is what Robert thinks. Like that is the same principled logic that he's employing in saying that No, it's the whole rest of the universe that moves around the Earth. And that's why it looks like we can observe stellar parallax. We can observe Foucault's pendulum. We can observe all the things that would suggest that the Earth is moving. He's saying that that's all caused by these forces that are Mach's principle, which is these weird action forces. Even though the formulas of gravity die off very quickly with distance, he's proposing that there's some sort of weird, strange, undiscovered physics behind Mach's principle. There's some sort of creepy force that's causing all of these forces on the Earth that's actually being caused by these distant stars. It's very, very silly. And just keep that in mind for all his arguments, because if I bring up Foucault's pendulum, he'll just say, oh, well, that's caused by, Mach explained this because all of the stars around the universe are moving, and that's somehow causing the force here. But we can make models that have a Coriolis effect. And the only way to get those models to show a Coriolis effect is to have them rotating, right? If you rotate a bunch of stuff around these models, you don't ever observe a Coriolis effect in the model. But you do observe one if you rotate the model. It's basic common sense. If you look at any solar system, because we've observed literally hundreds of other solar systems, every single time the planets rotate around the star. We never observe even a single instance of the star rotating around a planet. We never observe it. So for him to say that that is the case in our solar system just sounds like a special pleading fallacy, which is a failure of logic. So yeah, I mean, in his model, you could literally just replace, he'll show a neat little model. I was thinking he might show it tonight, but he didn't really show any visuals. But you could just replace Mars or Pluto. You could replace any of this arbitrarily and you get the same results. I mean, they're equally as consistent as Robert's model. So it's literally just a little trick that he's employing, a trick of just changing the frame of reference. He's got nothing other than tricks that, like, literally just anyone on the street can see is very silly. I mean, ask them about the guy falling from the skyscraper. Everyone thinks, yeah, that guy is falling. It's not the rest of the universe that's moving up to meet him. It's the same exact level of silly stupidity that we're hearing on the other side tonight. So I'll just, whatever my time is, I'll cut it there and we can go to open discussion.
Okay, thank you, Grayson and Robert, for the opening arguments. Let me restart the timer. We're going to jump into an open discussion. But what we'll do, since Grayson just finished his arguments and bringing forth some objections, Robert, let's give you a little bit of time. There might be a few things you want to address, and then we'll pick kind of one point or one topic, and we'll run with that for a little while.
Okay. Grayson, let me just address you first. Okay, look, if you want to come into a debate and call your opponent's view, stupid, silly, full of tricks and all this stuff, if I had known that, I wouldn't have debated you. Okay? If you want to be a scientist and examine the merits and demerits of someone's theory, that's one thing. Okay? It sounds to me like you already made up your mind before you came to the debate that this was stupid and silly. And, whatever I say, here's what Robert's going to say, and you sort of, cover all the bases before I even get a chance to explain or rebut what you've said. Okay. Now, if that's the way you want to debate, go debate somebody else. I'm not interested in, schoolyard tactics that you're trying to play here. Okay. So do you want to give an apology at first so we can move on, or are you just going to maintain this stance that you have that everything that I say is silly and stupid?
Well, no, I arrived at the conclusion that it was silly after having listened and examined what you were saying.
You
so
didn't.
It's not like
I never met you. Okay.
Yeah.
I just gave my argument here. You're basing it on some conception you have otherwhere that you got about me, and that you made up your mind before you came to the debate. A debate is supposed to be fair, sensible, so that each person gets to give his side of the story without being, beat up before we even get to the discussion period.
And
Well,
Grayson, before you start, I do want to add to that. Yes, let's keep this debate professional on the science. We do a lot of debates here, and I'm sure certain opponents of different topics, they'll believe that the topic they're debating is silly. But let's keep it sophisticated. Let's keep it cordial, and let's not engage this topic in poor taste. Grayson, you've been here many times before. We don't like dumpster fires here. We really like to just engage the arguments, but let's really avoid the extra rhetorical nature of the argument. Let's avoid the word stupid, silly. Let's really just focus on each other's points, if that's okay with you, Grayson, and feel free to respond.
Yeah, I just want to clarify that I never made any ad hominem. I never said Robert was stupid himself. Okay, I was addressing his arguments as being silly, but if he doesn't like my use of adjectives to describe those arguments or characterize them, fine. I will not characterize his arguments with any adjectives. But I just want to say, I'm totally open to having a back and forth, going point by point and going into the details and the weeds here. I mean, personally, I would prefer formats without any openings, just so we can literally go point by point. But yeah, because we were doing
openings. Let me give you an example, Grayson, okay, of what you called stupid that wasn't stupid.
Okay.
You made it sound like I didn't even address the topic of ether. You said that at least 2 times in your opening statement. That Robert didn't tell you about ether. And that tells me that you've already prepared your arguments before you even listened to me. I specifically mentioned ether as probably one of the first things that I talked about, especially with the Michelson-Morley experiment. Okay.
So,
and I said that the way Einstein would deal with that is to take away the ether. And everybody had believed in ether. Okay. And you came and you said, well, Robert didn't tell you about the ether. And here's a simple way to deal with it. We just don't have any ether. Okay.
Yeah,
that's what you did.
To clarify, I was, in the first regard, talking about the Airy experiment. You never once mentioned ether in Airy's results, which is kind of key to the results. But I did say that you had mentioned ether, but you just did not mention them when you were discussing the actual results of those experiments.
I did. The first one I mentioned that had ether was the Michelson-Morley experiment. Okay. So that should have told you right away. I knew about the ether issue. Okay?
I know you know about it. That's why I would like to actually discuss the issue then, rather than just say he said, she said kind of drama. Yeah.
Well, what I'm saying to you is don't call it stupid when I mentioned the very thing that you said I didn't mention. Okay. Now, I didn't mention it for Airy. You know why? Because nobody has ever used the ether solution for Airy's experiment. No one. Okay. You're the first one. You know why? Because it doesn't make any difference whether you use ether.
That's actually
going to determine whether the light beam comes in straight or not.
It does actually.
No, it doesn't. Nobody's ever said that. Show me one person who said that.
If ether is present, then we would not expect for Airy's results, the one that we observed. But if ether is not present, then they're totally in line with what we observed.
I don't buy that at all. What scientist has ever used ether to answer Airy's experiment? Just gave me one.
You can literally just go read the Wikipedia page for Airy's experiment. It'll talk about it.
Yeah, well, I've already read it, and there's nobody there that uses ether, okay? That's why I'm saying it to you.
All right.
Now, I'm not going to call you stupid, okay?
Good.
I'm just going to call you just don't know about the Airy experiment, and you've already had your remarks prepared way ahead of time, okay? That's what I'm complaining about to you. So if you want to debate, let's debate. You don't debate calling your opponent stupid before he has a chance to.
I didn't call you stupid.
Well, you came close to it.
I feel like you're getting very defensive on this when I would prefer to stick to the substance.
Because look, I've been in hundreds of debates. Okay. And anytime somebody tries this, and it's been very few times, maybe one other time somebody has tried to pull this stunt, I'm going to call you on it.
So are we debating about the debate now, or are we debating about the topic?
Johnny, I've had enough. Okay? It's over.
Okay, just run away.
Well, great. Okay, well, I guess we attempted to get a debate on something geocentric related or flat earth related, but this could be a sign that on Standing for Truth, where we do like to keep the debates as professional as possible, as sophisticated as possible. You know, these kinds of topics might, there's some people in the chat saying dumpster fire. So, well, I guess we're going to call the debate since your opponent's not here. Grayson, we did have an excellent audience, as we do have over 100 people currently, but with only one debater here. So I guess we'll call it here, Grayson, if you wanted to say a final word, or maybe we'll wrap it up. You know, this is probably the most we're going to get on this topic. So, okay, here we go, guys. See you later.